Okay, so you've seen a magic trick. You've gotten to play with a couple of different Mr. Potato Heads. Can somebody explain to me one strategy that your group used to determine all of the different pairings? Yes. So you counted each of the body parts and you categorized and how many in those categories, okay? Did somebody do a different approach? Yes. Okay, what formula? What did you do? So you just squared the number of body parts. You made a formula, squared the number of body parts, okay? What are some other approaches? Yep. You just guess, okay? All right. What else? I saw some other strategies out there. Yep. Okay, so you just basically kept putting pieces of outfits together and then tallying as you made up a new outfit? Any other approach? I saw some group counting up total number of body parts. What did you do with that? Like total number of parts that were in the box. What did you do with that? You did what? You took the number of parts and you put it exponentially to the fourth. Why did you pick fourth? It sounded the coolest. All right. I will tell you that in the last, did you have another response? Okay, that's another good one. You counted how many little holes that the potato had, okay? So we're going to talk about those. In the last class, some people made some factor trees. You might remember that when you studied probability. I'm going to go and we're going to look at the spider spud. So, spider spud. I'm going to look at the first, okay? The first strategy I heard you guys talk about is actually the fundamental counting principle. So we're going to start with feet. And this particular one has two options for feet. So I would have feet, and I would have two because there's two options for feet. Now this is going with the guidelines that it has to have feet, okay? All right, so then next we have to have arms. And this particular one has two options for arms. So arms, two. And then this particular one has four different head choices. So four heads, and then it has a spider web that it can go with or go without. So that is two, with, without. Accessory, two. And we would multiply this together. That is the fundamental counting principle. You take the options for each category and you multiply it together. So in this case, 4 times 4 is 16 times 2. There were 32 outfits. Okay? All right. Another strategy. Another strategy goes with factorial. It also will go with permutations, which we're going to talk about today. And I heard somebody say they looked at the spud and they counted how many openings it has. So this one has 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. Okay? The total number of parts are 1, 2, 3, 4, 5, 6, 7, 8. There are 9 pieces. So I pick one accessory and I take it out. So instead of having 9, now I have 8, and then I have 7, 6, and 5. Using this, we end up with 30 times 7 is 210. 210 times 72 is 0, 2, 4, 20, 0. I know. 0, 7, 14. So we end up with 0, 2, 1. Oh, sorry. 15,120 if I did my multiplication right. Okay? All right. We're going to study these two today. We will study combinations tomorrow. I'm going to give you a note sheet for us to look at. Okay, sorry, I wasn't very clear. In this scenario, we're saying that order does not matter. That's what's special about permutations. We are saying that the feet could be where the hole for the head is and stuff like that. And so that's why we got all these extra additional combinations, okay, or permutations. Arrangements, configurations. I'm trying to avoid using the math terminology so I don't confuse and misuse those. All right. Okay, we're going to start with the fundamental counting principle. And we have an example. For a college interview, Robert has to choose what to wear from the following. Okay? So, he can pick from 4 slacks, and then 3 shirts, 2 shoes, and 5 ties. So how many different outfits could he make? Okay, so we have 12 times 10, which is 120. All right, are we good? All right, let's look at another fundamental accounting principle. We are going to look at the Texas license plate. The Texas license plate has a letter, then it is followed by 2 digits, and then 3 letters. And they're saying that the letters and digits can be repeated. So if there's an A, there can be more than one A on the license plate. Everyone follow? In the English language, how many letters are in the alphabet? 26. Now, this one gets everybody. How many digits? There are 10. Remember, 0 counts. 1 through 9 and 0 makes 10. And we're saying they can repeat, so another 10 times 26, 26, 26. So either using your phone or a calculator, please multiply those numbers together and tell me how many different combinations of Texas license plate are there? Okay, I know this is not proper math, but it's easier for me to record it. Can somebody read the digits to me? 4, 5, 6, 9, 7, 6, 0, 0. So that is 45,697,600. Yes? Okay, let's change it up. Now, first of all, there's actually more than that. Because if you think about it, here in the state of Maryland, you also have different backgrounds. You have the War of 1812. You have the Shield. You have Save the Bay. You know, so some states have multiple backgrounds, okay? They could. They could allow that. Then you have alumni tags and different things like that. All right, so we're going to change this, however. Texas now says that once you use a letter on the tag, you can't use it again. So the first position will still be 26 times 10 times 9 times 25, 24 times 23. How many combinations does that get me? Okay, say it to me. 3, 2, 2. Hold on. 3, 2, 2, 9. All right, so 3,229,000. Oh, there's one more 0? Okay. So that changes it. So it is 32,292,000, yes? Okay. Now we're going to talk about permutations. Permutations, the order matters, okay? And permutations, you're given extra detail. So think of it this way. I could say that we're running a race in this class, and I'm going to give a gold medal, a silver medal, and a bronze medal. In that case, the order matters. I could have also said instead I'm just going to pick the 3 fastest, and they all each get a prize. That would be combination. If who finishes where matters, that is permutation. If the order does not matter, that is combination. So let's look at my friends Jack, Bob, and Alice. And they're going to line up for class, okay? So one order would be Jack, Bob, and then Alice. I could go Jack, Alice, Bob, right? I could go Alice, Jack, Bob. You get the idea, correct? Okay. So we're going to first do the order by doing the fundamental counting principle. And to be honest, most of the time with permutations, that's what I use. I don't go into the full factorial. Okay? In this case, I have 3 spots. How many kids do I have to pick from? And now how many? 2, because once I pick who's standing first in line, I have 2 people to pick from left, and 1. Okay? So that is 6 different arrangements of these students. Okay? This would also be known as 3 factorial. 3 factorial. Factorial is when you have a starting number and you work all the way down to 1. Please note that 0 factorial is 1. Similar to any number to the 0 power is 1. Same thing. Okay? Because we always have 1 at the end. Factorial is all the digits and then 1. Questions? Yes. Would. How many permutations? Yes. The number of permutations is 6. And we use the fundamental counting principle to do it. Okay? Now, we're going to figure out the number of permutations, okay, for doing A, B, C, D. Okay? So, I have A, B, C, D. How many letters do I have? So I'm going to make a 4-letter arrangement. How many letters can I pick from? 4. I chose the letter C. How many letters now? 3. I chose A. How many? I chose D. How many? 1. Notice, I began with 4, and I worked all the way down to 1. So this is 4 factorial. And this happens to be 4 times 3 is 12, times 2 is 24. Okay? Factorial is when you take the number and you keep decreasing it. We are going to look at the following factorials, please. 4 factorial. Okay, Gideon, what number am I going to start with if it's 4 factorial? 4 times 1, which equals 24. Okay? If you will notice, there are 3 additional examples. Would you please work on those now, and we will go over those. Okay, let's look at the next example. 3 factorial is 3 times 2 times 1, which equals 6. Okay, the next one is 6 factorial. 6 times 5 times 4 times 3 times 2 times 1, which is 30 times 24, which is 720. Last one. Now, I personally write out the last one before I do the work. So what is 5 factorial? 5, 4, 3, 2, 1. And underneath I should have 3, 2, 1. Now watch what I do. If it's in the numerator and the denominator, it cancels. So I'm left with 5 times 4, which is 20. And that's where we're going to stop the lesson today.